Sir has taken up natural language processing uh, for the first session, and it will be continued for the second session also. It would be a hands-on session, as you can see. So I hope I'm audible. And sir, are you here?
Yes, madam, I am there.
All right. So you may continue.
Thank you very much, madam. Thanks for the opportunity. So let us begin our second session. So let me share the screen with all of you. So just to recapitulate, I'm just giving you the overview, whatever we have covered in the first session. So we were discussing about the word embedding. So first of all, we started with a basic introduction with natural language processing, and then we have learned what is word embedding. Okay, then we have seen about, we have discussed about pen tree bank data sets. Then we have started to installation of the necessary modules. After installing necessary modules, we have discussed about the reading and pre-processing of the data set. Then we have checked the vocab sizes through the code. Then we have implemented subsampling. Okay, the benefit of the subsampling is that the higher the word frequency, the higher will be its dropout probability. That we have seen. We have incorporated those things through coding in Colab. Then we have also implemented or generated the graph, where we have seen that in both the cases we have generated a token per sentence versus count graph, and we have seen that subsampling can significantly reduce the sequence length. Then, for example, we have checked the individual token performances through the subsampling, how it can be reduced for the high frequency words, like we can reduce it by 120 times. Okay, for example, before subsampling, it was appeared 50,770 times, but after subsampling, it has reduced to 2183 times. Then we have seen, for example, low frequency words like join can completely be preserved. Okay, before and after both the cases, it was 45. Okay, then we have we have mapped the index to construct the corpus. Okay, then we basically extract the central and context words through get, centers, and context function. Okay, then we have made a sample. We have defined a sample tiny data set. Okay, which consists of the 7 and 3 words. Okay, and where we have considered the context window, maximum context window 2, and we have generated the center and their context. Followed by that, we also generated with the maximum context size window size 5 for all the central target words and their context words in the data set. Then we have incorporated negative sampling. Okay, we have defined the random generator. Okay, and we have seen the outcomes in the range 10. And then with the after the definitions of the negative sampling, now we are going to discuss about the reading into batches. Now we see that so far we extracted all the target words under all centers, all the context words under all context, okay, and noise words under all negative functions. Okay, now in a mini batch, we will see that for example, in ith example includes a central word and correspond ni context words. And if we see the corresponding noise words is mi, then what will happen that the window size of each example may be different. Okay, so the sum of the context words and the noise words, that means ni plus mi will be different. So when constructing a mini batch, we can concatenate the context words and the noise words for each of the example by adding 0. Okay, that we call padding, 0 padding, until the length of the concatenation becomes same. Okay, so it will make the length of the concatenation max I ni plus mi max length. Okay, so through padding we can bring down the homogeneity in the addition. Otherwise it was different, the window size will differ. as per the length of the context words and noise words. So by adding padding, we are bringing down the parity of the summation. Now, in order to avoid the effect of padding on the loss function calculation, we construct the masks variable, which we are defining as the masks. Okay. So what will happen then? Each element of the corresponding of in the concatenation of context and the noise words, okay, we can mark it as the context negatives. So what will happen then? When an element in the variable is context negative under padding, the element in the marks variable will be in the same position. It will be 0. Otherwise, it will be it can take the value 1. So in this way, masking will be able to distinguish between the positive and negative examples, and we will be also need to distinguish the context words from the noise words, okay, which is present in the context negative variable. So how can you do that? So based on the construction of the mask variable, we only need to create another variable that is called label. Okay, so label with the same shape with the context negative variable. So set the element corresponding to the context word for the positive example 1, and for the rest of the cases 0. So to positive and negative identification, you are doing labeling for positive word 1, negative word 0. And to identify the padding, what you are doing the masking. So for the padding cases, masking will identify it, and it will remove the effect of the padding such that loss functions can be calculated appropriately. Okay, so that's the overall scenario. Now we will incorporate all those things in Colab. So what will happen, that mini batch reading function is used here, that is the batchify. Okay, so its mini batch function will take the input data. Okay, so what we are defining the mini batch function, where it is taking the argument input as data. Okay, and we will, along with that, we will define the centers, context negatives, mask, and labels, and we will see what type of the outcomes we are getting here. So basically, you can see that maximum length, as per our earlier discussion, it will be maximum length of C plus N, where C and N present in the data. Okay, then what we are doing, we are basically initializing centers, context negative, and for example, mask and labels. Okay, and followed by what we are doing, we are putting it in a for loop. So current length equals to length of context plus length of negative. Now centers equals to it will be updated center plus center. Then context negative will be updated accordingly. Okay, it was basically initialized at context plus negative plus 0 into maximum length into correct length. Okay, so masking now, you see, with the current length into 1 plus 0 into maximum length minus current length, that means padding. Okay, so it will be indicating 1 for the non-padding cases. For the padding cases, it will be 0. And the labeling, how can you do the labeling? The labeling will be done for all the positive cases 1, negative cases 0. Okay, and at the final cases, you will be able to see the return in terms of the defined shapes for centers, context negative, and mask. Okay, so I am sending this particular portion in your comment box section. Okay, just run it. And let me know if you have been able to run it successfully. Okay, then we will, after running it successfully, what we will do, we will now check 2 sample examples. Okay, with the defining x1 and x2, and for the, then we will batchify it. Okay, and then we'll print the each outcome cases. For example, for centers, context negative, masking, and corresponding labeling. Okay, so already Raju sir has said that he has been able to done it successfully. So I am requesting rest of the respected faculty members to kindly let me know whether they have been able to done it or not. Thank you, Somadev sir. So it's 11:39. I am expecting that by 11:40, all of you can complete it. So make sure the spacing cases. So let me go back in case you are facing any difficulty related to indentation error. So this is the follow the spacing has been given there, one spacing for after defining immediate line, after defining the function, batchify function. Then you see after defining the for loop, first line of the for loop in the next line, whenever you are going, make sure that you are putting the proper spacing. Okay, then another thing will happen, return, and there and then the line of the return. Okay, it will be same line aligning with the for loop line. Okay, so that type of spacing you require to maintain, otherwise you may face some error, indentation error. But the benefit of the collab is that it automatically indicates that from which how much portion of the spacing you have to give. As the auto indicator is quite helpful. Pankaj sir, thank you, Pankaj sir. So let us wait for a few more seconds, then we will execute the next part. Okay, thank you, Indumati madam. Thanks a lot. So I believe that all of you have been able to define the batchify function correctly. Now we will move to the next part. So here you see we have defined x1 and x2 in the next part, and then what we have done, we have taken those two x1 and x2 under the arguments of the batchify function. Okay, then what we are doing, we will print centers, context negative, mask and labels. We are assigning them under the names. Okay, and then what we are doing, we are simply printing them out. Okay, so in the format of print name equals to data. Okay, so that means each of the part under names, there are 4 parts: centers, context negative, mask and labels. So each of the name will appear. For example, centers, then it will follow equal sign, then it will print the output of data. Same thing for the context negative, mask and labels. Okay, this is how we have printed. So that's the reason under print we have written like name comma with equal sign comma data. So according to, in this manner, aligned manner, it will keep on printing for the centers, context negative, mask and labels. Okay, so I am sending this part of the code in your comment box section. Kindly let me know once you are able to run it. Okay, thank you, Aisa madam. Okay, so let me post it. Just run it and let me know. So it's 11:42. I am requesting all of you to complete this step by 11:43 or 44. Next 1 or 2 minutes, kindly complete it. Thank you, Raju sir. Thank you, Somadeep sir. Thank you, Shamali madam. So we shall wait for a few more seconds, then we shall move to the next part. Completed. Okay, thank you, Aisha madam. So I am expecting that all of you have been able to incorporate this successfully. So we shall move to the next part. Okay. So we have utilized batchify function to define the mini batch reading method. Okay. Now you will see the data loader instance putting them all together. Now it's our time to put them all together. Okay. So we shall define one particular function that will be data load data PTB. Okay. That can read the PTB data set and can return the data iterations. Okay, so thank you, Pankaj sir. Thank you, Indumati madam. Okay, so all of they have been able to successfully complete the steps. Now let's move to the next part. So what we are doing, we are basically, first of all, we are defining the load underscore data underscore PTB. Under that, there are several arguments you can see: batch size, maximum window size, okay, and the number of noise words. So then we have defined one by one num workers, for example, to D12 dot get underscore data loader underscore workers, which has been loaded under the num workers. Okay, sentences has been assigned with read PTB function. Vocab has been assigned with D2L vocab, where we have taken the sentences as the first argument, and mean frequency we have kept for 10. Okay, then subsample has been done with the subsampling function, which has been acted over 2 argument sentences and vocab. Corpus has been defined with vocab line for line in subsample. Okay, in this similar fashion, we have defined all centers, all context under get centers and get and context function, where the arguments are corpus and maximum window size. You already have discussed all those things earlier, how we have defined those functions. We are putting them all together here. Okay, all negatives has been assigned with the get negative function, where the arguments were all context, corpus, and num noise words. Data set, you know that gluon.data array data set, where we can take the arguments like all centers or context or negatives. Okay, and data iteration has been defined with gluon.data loader, where we are taking the data set, data batch size, shuffle, we are putting shuffle equals to true. Batchify function, okay, where we are taking one of the arguments, now markers equals to has been assigned, and then we are returning data iteration and vocab. Okay, so that was the main objective, that to define the load data PTB function, where we are putting all those things and we are returning the data iteration. Okay, and then in the next part we will print the mini batch for the data iteration. So this part please incorporate, okay, such that all of you can successfully call the data iteration. Let me know once you are done. Then we shall move to the next part of defining the mini batch of the data iteration. So it's 11:47. I am expecting by 11:49 all of you can complete it. Okay, thank you, Shamini madam, thank you, Raji sir. Okay, thank you, Aisha madam. Thank you, Somadip sir. Thanks a lot for all of you for kindly acknowledging me. It is helping me to progress further of the session. So I am requesting respected faculties to let me know such that we can move further. I believe this portion of the code is running successfully. All of you have been able to define the load data PTB function successfully and returning the data iteration successfully. Okay, so Indumoti madam, thank you very much. Now we shall move to the first mini batch of the data iteration. We will print it. Okay, so I believe that all of you are doing it quite smoothly. So moving to the next section. So what we are doing, we are defining data iter, vocab, data load PTB. Okay, so 512 is our basically the batch size. Okay, and for the batch, what we are doing in data iter, we are defining for name, data in zip, names and batch. Okay, then we are printing name, shape, okay, and data dot shape, and we are keeping the break in order to get out of the loop. So now what type of outcome you will be able to see? You will be able to see the center and corresponding shape, context negative and corresponding shape. Batch wise you will get the outcome of the shapes, mask and their corresponding shape, labels and their corresponding shape. So these 4 outcomes were required for the batch wise. So for the first mini batch, these are the corresponding outcome as per their shape. We are being able to print it out. Okay. So just incorporate this portion of the code in your comment box section and let me know. Okay. Thank you, Raju sir. Thanks a lot. So putting this portion of the code in your comment box section, just let me know for the first mini batch of data iteration, whether you are able to run it successfully or not. This is 11:50. I am requesting all the respected faculties to kindly complete it by 11:52. Okay, thank you, Raju sir. Thanks a lot. Thanks, Somadev sir. Thank you, Indumati madam. Thank you, Shomoli madam. Absolutely, Somadev sir. This will be the outcome. Thank you. Thank you, Aisha madam. So I believe that gradually all of you are being able to get the output by running the mini batch of each data iteration. So for the help of all of your cooperation, we are being able to complete the first notebook. Okay, so what we have learned so far, if we check this summary, so subsample attempts to minimize the impact of high frequency words on the training of a word embedding model. This is the first point. Secondly, we can pad the examples of different lengths to create the mini batches with the example of all the same lengths, and utilize the mask variable to distinguish between padding and non-padding elements, because only non-padding elements will be utilized in the calculation of the loss function. Okay, so this type of scenarios we have already incorporated in this first notebook. Okay, so I will share the notebook to the organizers after the session, so they will definitely send it to you. So nothing to worry about it. Those who have already successfully incorporated, they already know how to incorporate in the practicing, while practicing in the home. If some of you have not been able to do it due to poor network connection or whatever may be the scenario, you can practice it later on. But I believe that most of you have already incorporated and reproduced those results, and the theoretical part is also there in the text section, so you can do it. So we are moving to the next notebook. So I would request all of you to open a fresh notebook, okay? And you can give some name like NLP2 or something like that. Okay, so where we'll incorporate few more examples, okay? And we'll see few more scenarios related to NLP. Okay, so kindly open the new one fresh new notebook. Okay, so what you can do, just look at the screen. So here you see you can go to file and you can create a new notebook. Just click on new notebook, one new notebook will be opened. Okay, and go to the untitled section and you can keep NLP2 or something. You can give some name like that. You may give NLP2 practice or something like that for your practicing purpose. Okay, so please open that, and meanwhile I am going to my next notebook where we shall discuss the next part. So here we will discuss related to some stuff related to pre-training of the word to vec. Okay, so in this section what we'll do, we will train a skip-gram model. Okay, in the skip-gram model, what does we do? In the skip-gram model, we assume that the context words are generated based on the central target words. So for example, father loves son, or father loves his son. Okay, now if the loves is basically the central target word, with the help of that particular central target word, you can generate the words like, for example, context words like father, his son. Okay, so in this way you can generate the context word with the help of the central target word. So this particular model is called the skip-gram model or SGM model. Okay, so at the first step, our first step will be to import all the necessary packages and the modules for the experiment. Okay, and load the pen tree bank dataset or PTB dataset. Now you see, like every cases, I have added some note on code in case you face some difficulty while understanding certain steps or what is the requirement of certain modules. So I have added there. Okay, so basically you see that what we are doing, first of all, it's the same step: pip install mxnet, pip install D2L. Okay, so as a deep learning framework, we're installing mxnet and all these supportive all these supportive activities provided is the D2L. Okay, from mxnet we are importing AutoGrad, Gluon, NP, NPX. Okay, and then from mxnet Gluon we are importing NN neural network, and from D2L importing mxnet as D2L. Now, for example, you see that MPA, NPX, like I told you that in earlier session also, that that NPX is the benefit of avoiding versioning. Okay, it avoids the version dependencies issues. So you do not require to unnecessarily go for certain packages, downloading certain packages and run after them. You do not require that. NPX makes the version independent. Okay. And then, for example, npx.setup, it is basically setting up the NumPy shape and array semantic at the same time. Gluon, like I discussed earlier, this is the interface which makes the execution of the deep learning model quite faster without executing any training speed. Okay, so this is how you can do during the initial setup of all the necessary packages. So I am sending this particular portion in your comment box section. Okay, here you see that we have defined the batch size 512, maximum window size 5, max noise word 5. Okay, and data iter vocal, okay, which has been assigned with the data to d2l.load data ptb function. Under that, we are defining batch size, maximum window size, and noise words. Okay, so I am just sending this portion in your comment box section. So please make sure that you are running it correctly. So once you are running it correctly, you can see these following outcomes will be come up. Okay, successful installation of D2L, and all the other aligned requirements will be satisfied. Okay, so this type of outcome setup you will be able to see. So let me post it in your comment box section. Let me know once you are done it. So this is 11:57. I am requesting all of you to kindly complete the basic installation processes of packages and all by 11:59. Kindly let me know by commenting in the comment box section. Thank you, Shomodeep sir, for your continuous support. Thank you, Indumati madam. Thank you, Samali madam, for your continuous support. So let us wait for a few more seconds, then we shall move to the next part. Just a second, let me check for getting error. Okay, thank you, Sujata madam. Pankaj sir, in which example you are doing? You are in the earlier notebook. Please open a new notebook. It was the earlier example. Whatever the output you have got, I can see it was the part of the first notebook. Last example of the first notebook. So we have moved to the fresh notebook. We are installing all the necessary packages there. So I am requesting Pankaj sir, you just install all the necessary packages there, because the output you are showing, that is the part of the last example of the first notebook. And you have got the correct outcomes: center shape, context negative shapes, mask shape, level shape. That was the expected outcome. All of the respected participants have already done it. So I'm requesting you to move to the next notebook, open a new notebook, and install all the necessary packages. You see the comment box section. For those who have not done it, I am just reposting it again, such that it can help them. So check that. Kindly, you just make sure that you have installed all the necessary packages. Go to fresh notebook. Please install all the necessary packages and modules. You will be able to run it smoothly. Please leave the earlier notebook, go to a fresh notebook. We are doing a fresh set of tasks here. Okay, so let me move to the next part. So all of the necessary installations have been done. Okay, so like we were discussing that in the skip down model, the main thing is that we have to implement by using the embedding layers and the mini batch multiplication. Okay, so these methods are often used to implement other natural language processing applications as well. So what is embedding layer? So basically in this layer in which the obtained word is embedded. Okay, now due to that particular reason, it is called the embedding layer, and it can be obtained by creating nn.embedding instance, okay, in high level APIs. So the weight of the embedding layer is, at the end of the day, it is a matrix, okay, where the rows of the dictionary size, which can be defined with input underscore dimension, and whose number of the columns is the dimension of each word vector, which is assigned as the output underscore dim. Okay, and if we set the dictionary size to 20 and word vector dimension to 4, then let's see the scenario. What will happen in the coding section? If you see the coding section, that like we have written in the above text section, that we are utilizing nn.embedding instance to create the embedding layer. Now under that there are two arguments, okay, input dimension and output dimension. Now you see that the input dimension is indicating the dimension of the dictionary, so we are putting it 20, okay, and output dimension is indicating the word vector dimension, we have given it as 4. Okay, now you see we are initializing it, and then we have embedded weight. So according to that, the output you will get, okay, parameter embedding weight shape 24, okay, and the data type float 32. Okay, so this output you will get. So I'm posting this portion of this chunk of the code in your comment box section. Just make sure you are running it successfully. Okay. Am I audible or I am not audible? Kindly, can anyone confirm me? Sujata ma'am has said I am not audible.
You're audible, sir, but sometimes it is fading away.
Okay. So I'm trying to make it much more consistent. It may happen that due to the distance of the microphone has been.
Right, now you're audible.
It's not working or something like that. So that's the reason it may happen. Okay, so it is audible now, right? Okay, so let me confirm that whether you are able to run this chunk of the code. Okay, so Sujata madam, Rani Panikar madam, okay, Somudip Ghosh sir, Lalita madam, thank you very much. Okay, this type of output you will get. Thank you, Somudip sir. Thank you. And Subhasri madam, thanks for the confirmation related audio related matter. Thank you.
Welcome.
Acha. Acha, Somali madam, thank you very much for the confirmation. Sujata madam, you are getting the correct outcome. So I am requesting all the respected faculties to complete the step by 12:06. Okay, so it's now 12:05. Okay, so Indumoti madam, thank you very much. So now let's move to the next part. Now input of the embedding layer is at the end of the day, it's the index of the word. Okay, so if whenever we are entering the index I of word, okay, so embedding layer will return the ith row of the weight matrix as its words vector. Okay, now below what we are doing, we are putting the index of the shape 2×3 into the embedding layer because the dimension of the word vector is 4. So what will happen that we will obtain a word vector of shape 2×3×4. Okay, so what we are doing, we are basically defining a numpy array, okay, and assigning it to x, and then we are implementing it over embed x, okay, and then you will be able to see the following outcome. Okay, so if we enter an index of shape 2×3, we will be able to see the dimension of word vector is 2×3×4. Okay, now let me just post it in your comment box. So requesting all of you to please finish it in next 1 minute. Now it's 12:07. Please make sure that you are completing it by 12:08. So once you are completing it, we will move to the skipgram model forward calculation. Okay, we'll see that how we can do the forward calculation where the input of the skipgram model will contain the target, central target word index, okay, which we are defining with centers, okay, concatenated text context, which we are defining with the context, and obviously the negative index. Okay, so that we will incorporate one by one. So while implementing the skipgram bash size, 1, and the context and the negative variable altogether, it will have the bash size, maximum length. Okay, so while we are putting it in the embedding layer, so in the embedding layer, what will be merged. So what will happen? The current shape, output shape will be bash size, 1, maximum length, like we have seen in the earlier cases. Okay, so in the earlier case, what we have seen that the weight matrix, when we are taking the input index shape of 2×3, we are getting the output of the shape 2×3×4. Why? Because our word vector dimension was 4. So have you been able to incorporate that part? Okay, thank you, Raju sir. Thank you, Sujata madam. Somali madam, thank you. Okay, thank you all. Thank you all. So let me share the screen. So let us go through the skipgram forward calculation. So here you see how we are defining the skipgram function. So first argument, as a part of the first argument, we are taking center. Okay, then context and negatives, and then embed v and embedding. Now embed v is defined over the center. Okay, center word, target center word, which we are assigning as v. Okay, and in the next case, what we are doing, we are basically taking the context and negatives as the function of embed u, okay, which we are assigning under u. Then what we are doing, we are simply doing npx dot batch dot, okay, where we are basically incorporating the dot product. Now v, comma use swap access. That means the accesses will be swapped to incorporate the dot product. That means vector will become the rows will become the column and columns will become the vector. Okay, and then we are returning the predict. Okay, then we will check the output shape of batch size, comma 1, comma maximum length. So first you just complete the defining of this skipgram function, because we are incorporating skipgram model forward calculation. Okay, so make sure that you are defining it properly. Let me know once you are completing the particular step. So then we will move to the next part, verification of the output shape. So it's 12:11. I am requesting to complete this part by 12:12. So I can see already our respected faculties started posting. Okay, thank you, Shamali madam. Thank you, Pankaj sir. Already they have posted that they have completed that particular part. I am requesting other respected faculties to kindly complete the part. Okay, then we will move to checking of the output shape. Okay, where the output will come up in the format of batch size 1, maximum length. Okay, Somodeep sir, thank you very much. Vibhakar Patak sir, thanks a lot. They all have been successfully completed it. So let us check the output shape. Okay, so with the help of this skipgram function, what we are doing, so we are basically giving the numpy array of ones with 2x1 shape. Okay, then 2x4 shape, and embed function that has been given as the input. Okay, and with shape extension. So you will be able to see that it is coming as the batch size 1 maximum length format. Okay, so the output will be 2x1/4. So I have posted the code in your comment box section. Please run this small chunk of code and let me know that whether you are being able to see the proper outcome or not. Then we will move to the training part. Okay, thank you, Pankaj sir. Thank you, Raju sir. So let us wait for a few seconds for the other respected participants. I believe they will be able to complete it. Okay, Somodeep sir, thank you. Sujata madam, thanks a lot. So I believe that all of you have been able to complete that part. Okay, and you are checking the output shape of the skipgram function. Now after successfully implementing the skipgram function, now we will go to the next part, that will be training. So we need to define the loss function before incorporating the training part. So binary cross entropy loss function can be defined, okay, as per the negative sampling, because in the negative sampling part we have the noise, so it plays an important role there. Such as Shamili madam, thank you. So you can directly use the binary cross entropy loss function from high level APIs. So here you see there is one function is there to calculate it, which can be assigned under the loss, that is gluon.loss sigmoid, okay, BCE loss. Okay, so BC stands for the binary cross entropy, and sigmoid function has been used as the activation function. So let me just post it in your comment box. Okay, make sure that all of you are running this single line of code just to define the loss function. Okay. So before going to training, we will check the loss function. So it is worth mentioning that we can use the mask variable to specify the partial predicted value or the labels that can participate in loss function to calculate the mini batch. So like we discussed earlier, that when the mask will be 1, that means the predicted value and the level of the corresponding position can participate in calculation of the loss function. And if the mask value is 0, they will not participate in the calculation of the loss function. So in this way, mask variable can utilize to avoid the effect of the padding over the loss function. So if padding is there, okay, it will not participate, it will indicate 0. If there is no padding, it will indicate 1. So in this way, the marks variable can be utilized to avoid the effect of the loss function. So in the meantime, our respective faculties have already completed the earlier step. So Indumati madam, thank you. Somadev sir, thanks a lot. Sujata madam and all those who have already completed, thank you. So now what we'll do, we will see that 2 identical examples where different level of mask lead to different losses. Let us check. For example, we are defining one numpy array and assigning it as spread. Okay, and then another numpy array is assigned as the level. Okay, now there are basically two different masks we'll use to check the what type of different loss we can get. So then we have assigned the masking value, and the loss function is comprising of the three arguments: spread, level, and mask. Okay. Now you see we will achieve this following type of outcome. Let me post it in your comment box section and just check it. Okay. So already we have defined the loss function. So under the loss function, we are taking three arguments. Spread stands for the prediction. Okay, leveling, and mask. Okay, with the help of these 3, we are being able to calculate the loss values. Okay, now yes, that unnormalized loss value will get. Then we will normalize it in the next step. Thank you, Pankaj sir. Thank you, Somadev sir. Thank you. Now our next task will be to normalize it. So I am requesting all the respected participants to complete the step by 12:19. Thank you, Sujata madam, such that we can proceed towards the next step for the normalization purpose. Okay. In the next step, we will do the normalization. Because due to various length, the result may vary. If we can normalize it, then the result will be standardized. So how can we do the normalization? So simply dividing the loss function with the help of mask, summation of the masks, taking the summation of the masks. So here how we can write it: Python sum.mask axis 1 into sum.sep. Okay. So how we are doing it? So let's check. Let's follow the following procedure. I believe all of you have been able to check the outcome. Okay. To check the different loss values. Now you see we are normalizing the step because due to the various length, the loss value will vary. So after doing the normalization, then you check it. So here we are simply doing the normalization step. Okay, I am posting the code in your comment box. Just check it. Requesting all the respected faculty members to complete it by 12:20. Okay. Now you check. This is the normalized loss value. That you will be able to get the same value. In earlier case, you are getting the half actually, because the mask value length has not been multiplied with 2. You see, predictive and leveling, these 2 variables have been multiplied by 2 factor. Okay, but in mask we have not used that multiplied by 2 factor. That's the reason it has created an effect while calculating the loss value. you are getting one loss value is double to another. Now we have what we have done, we have normalized it. So normalized means it will make the variable length independent. So according due to that, you are getting the same outcome, same effect in terms of the loss value. Yes, thank you, Sujata ma'am. Thank you, Somadip sir. Thanks a lot. So that's the beauty of normalization. In machine learning, deep learning, all the relevant applications, we often go with normalization. This is a very, very important step to make it scale independent. I'm requesting other respected faculties to kindly let me know if they have been able to incorporate the steps successfully. Then we will move to the initializing model parameters section. Okay, already Sujata Madam Somadip sir has informed me. So let us wait for a few more seconds and then we shall move to the next part. So let us now discuss about the model initialization of the model parameter. Okay. So we can construct the embedded layers of central and context words respectively and set the hyperparameter word vector dimension embed size to 100. We are setting up it as 100. Now you see that once you are defining embed size, assigning the embed size as 100, then what we are doing, we are basically defining net equals to nn.sequential. So neural network sequential. Now how we can do the sequential steps? So we can simply add the net.add by adding the embedding layer, okay, where the input dimension we are taking the length of vocab and the output will be dimension will definitely be the embed size. And next next nn.embedding step, the same thing we are doing. We are taking the input dimension as the length of vocab and the output dimension will be size. Okay, so make sure that all of you have done the model parameter initialization quite successfully. Okay, so by defining the embed size to 1. Okay, so I am just posting it in your comment box section. Just make sure that you are being able to run it successfully. The initialization step we have incorporated successfully. Kindly confirm me. Okay. Then we shall move to the training part. So before going to training, we have defined the loss function. We have done the model parameter initialization. Okay. So once you are done with the model parameter initialization, then we will move to the next part. Okay. And that we will do the execution of the training. So requesting all of you to kindly complete the step by 12:24. It's now 12:23. Okay. Then we will move to the next part. Okay, thank you, Somadip sir. So let us wait for a few more seconds, then we shall move to the next part. So thank you very much for all of your cooperations. Because doing things remotely is not very easy. It is not we shall not be able to get success of executing the hands-on session until or unless all our respected participants participate actively. And it's been pleasure to see that all of you are contributing in a large extent, and that's the reason the session has been progressing quite smoothly. So it's hats off to all of your efforts. Thanks a lot. Thank you, Raju sir. Thank you, Sujata madam. So let us now discuss about the training part. Okay. So in the training function has been defined below. Okay. First of all, just a second. Let me scroll it down. So here we will discuss about the few important aspects which has been used in the code. Okay, so first of all, I will talk about the CTX. You see that in the code you will often come across few of the session. So first of all, we will define the training function. Training function has been defined where the argument has been taken net, data item, learning rate, stands for the number of epochs. Okay, device D12 dot try D2. Now here you will see that device, in case of the device, you see the CTX has been applied. In the next step, you see date of initialization, CTX equals to device, and force reinitialization equals to true. Why it has been applied CTX? Now you see that CTX is a parameter which allocate the many more number of the tensors. So that's the reason we have assigned CTX equals to device. And the force reinit true. Why we have taken that? Because it makes the reinitialization of the variables. Okay, so reinitialization of the variables was very, very important while executing the training part. So that's the reason force reinit has been stands for the reinitialization is true. Okay, then we have defined the trainer with the gluon.trainer instance. So here we have defined the net.collect parameter Adam. Okay, learning rate where we have written the abbreviated format here. Now Adam, you know, it's a replacement of the optimization algorithm, which is replacing basically the stochastic gradient descent. Okay, while training the deep learning model. Now Adam is basically the hybridization of the adaptive gradient, which we call ADAGRAD in shorter format, and the RMS prop, which stands for the root mean squared propagation. Okay, to provide the optimized outcome, optimized algorithm outcome in order to handle this sparse gradient. Okay, which is not, I mean, and it is quite effective in terms of dealing with the several noisy problems. So in ADAGRAD, what we do, we basically deal with the second order movement with no decay. Okay, to deal with those sparse features. Okay, and in case of the RMS props, what does it do? RMS props stands for, as I told you, that is stands for the root mean squared propagation. So it basically uses the decaying average of those partial gradients, okay, while adapting the step size of each parameter. Okay, so these are the few things which are related to the code. Okay, so those has been assigned earlier. Now, how we are doing animator? So animator can be done with the D12 animator instances. So here we are taking the input as the X level, we are assigning for the epoch. Y level we are assigning for the loss. And what is the X limit we are giving? 1, number of epochs. Okay. Now we are defining the metric Y to check the sum of the losses. Okay. So D12 accumulator 2. Okay. So now for epoch in range, number of epochs, okay, timer, number of batches which has been defined with D12.timer, and length of the data iteration has been given there. Now for I, batch in enumerate data iter, okay, we are basically taking the center, context negative, mask and level. These 4 things we are basically considering, okay, and which can be accessed through the data.as in CTX device, okay, to allocate the large number of the arrays and tensors there. For batch, data in batch. Now autograd.record, okay, which is assigning, under that we are assigning pred variable with this, with the schemagram function, where these 4 arguments are being taken: center, context negative, net 0, net 1, and we are defining L equals to loss, okay, where we are basically taking the pred.reshape, level.shape with level and mask arguments divided by mask.sum axis 1 into mask.shape. Okay, so with that, again we have calculated the L.backward. One is the forward calculation loss, another one is for the backward, and then we are defining the trainer shape in terms of the base size, and how we are doing the metric addition, where L.sum, L.size, and then finally we have put that condition that if the modulo value, after dividing the number of batches 5, whether the modulo value is 0 or it is giving y equals to number of batches minus 1. Okay, and finally what we are doing, we are incorporating the printing the value that in this following format, that loss metric 0, okay, divided by metric 1, and followed by metric 1 divided by timer.stop, okay, which will be defined as a token per second on the STR device, string of the device. Now you see that we have defined the training of the model in this manner. Now, what is the next step? What we have to do? We have to keep it one thing in mind: the negative sampling construct the loss function by considering the independent in both can contain the positive and negative examples. Okay. Now you see the gradient computational overhead for each step in the training process is linearly related with the number of noise watts we sample. Okay, we are sampling. So here you see the learning rate what we are keeping 0.01, and epochs we have kept 5. And then we are training the under the train function, what we are the arguments we are taking: net, data eta, LR, and number of epochs. LR stands for learning rate and number of epochs. Okay, and you can get the following type of graph. But first of all, you have to define the train function. Okay, so let me put that chunk of code in your comment box section such that you can run that portion successfully, and then you can run the rest of the code. So due to the limitation of the word, the whole portion of the code has not been able to post it. I have not been able to post it in your comment box section. Okay. So what I am doing, I am sending you it in parts. Okay. So all of you, I am requesting all of you to please make sure that you are balancing the two portions, because all of you know that there is a limitations of number of words in your comment box section. So that's the reason what happens that the whole portion of the code I am not being able to send. So what I am doing, I am just resending it. The next portion, I am just resending it. Make sure that you are being able to run it properly. Okay, you are joining them properly and you are running it properly. Okay, so from my portion, I have completed the posting of the code. It has been sent in 2 portions. Okay, due to the limitations of the number of number of words in the comment box section. So now I am resharing the screen. Just make sure that all of you can see this. Just a second. All of you can see the screen and you can adjust it. Okay. So please make sure that you see that if I plus 1, that modulo sign, the single percentage sign in Python is the modulo sign, it is posted up to that. Then you just make sure that you are adding this num batches portion with it properly to complete up to the last line of the code. Okay, and make sure that you have added this proper spacing in the code in order to avoid the indentation error. I think some comment. Okay, the answer. Thank you, Raju sir. Thank you very much. So let us wait for other respected faculties. It is 12:34. I am requesting all of you to kindly complete the step by 12:36. Okay. So make sure that you are joining them properly. Joining the 2 portion of the code is very, very important. So in the first section, we have I have posted up to num batches. Sorry, this I think this modulo sign, and then followed by next portion of the code, I have again posted. So there you can complete the full part of defining the train function for the executing the training operation. Okay, done, sir. Okay, thank you Somadip sir. Thank you Pankaj sir. Thanks a lot for all of you for your continuous effort of making this session successful. So let me know. Let us wait for a minute for the other respected faculties to complete that particular step. Then we shall move to the next part. So I believe that all of you now able to resolve this particular part of defining the training portion. Okay, now what we'll do, I'm just moving a little bit ahead to give you the idea to how to check the epoch versus loss plot, where you can see that as the number of the epochs increases, the loss will be decreased. Okay, so here we have defined the number of the epochs 5 and landing rate 0.01. Okay, and then we are executing the train function. Okay, where we are taking the arguments like net, data item, LR, and number of epochs. LR for landing rates and number of the epochs, which we as we have defined earlier. Now, let me post that part in your comment box section. You will be able to generate the following plot. Okay. So it will take some time to generate the plot. Then once we are able to generate the plot, we will move to the next part, that will be the applying the word embedding model. So once you are generating the plot, let me know if you are getting the basic outlay of the basic layout of the graph, which were assigning the x-axis epoch and y-axis loss. And then this particular generation of this particular green line with the number of the epoch wise, it will calculate the loss. Okay, so it will take some time. Okay, so it will first move to epoch 1 to epoch 2. We will be able to see some portion of the line as generated. Okay, then it will move to epoch 2 to epoch 3. Then again, you will see some portion of the line has been generated to indicate the decay of the loss with the enhancement of the number of epochs. Then it will move to 3 to 4. You will see another progress, and there you will observe that another decay in the level of loss. And then finally, once you move to 4 to 5, the final touch of the graph will be done, where you will see the consistent decay of the loss as per the increment in the number of the epochs. Okay, so in this way, you'll be able to see that how the increment with the increment of the number of the epochs, you can see the reduction in the loss level. Okay, so just you may post in your comment box section that at least you are able to see the basic layout of the graph. It will take some time to generate the plot. We can wait for 5 minutes and then we can move to the next part, because it is a time consuming matter. It may take even 20 minutes to 30 minutes to generate the whole plot. We can move to the next part meanwhile. So you may try out at your home later on as well. Just let me know, as of now, just let me know that whether you are able to run the code flawlessly or not. Just drop your comment that it is executing the graph. That would be good enough. That means it will definitely execute the graph. It will take some time. On an average, 20 to 30 minutes it takes to generate this particular plot. Yes, sir, taking time. That means, thank you so much, sir. That means it is working fine. If it is taking time, all of you, please make sure that it is working. Okay, it will take some time to generate the plot. 20 to 30 minutes on an average, it will take. Okay, so let us move to the next portion, okay, for the discussion purpose. So applying the word embedding model. So after the training of the word embedding model, we can represent the similarity in the meaning of the words based on the cosine similarity. Okay. Now while calculating the cosine similarity of the two words, we'll be able to see when using the trained words upon the embedding model, the words closest in the meaning to the word chip are mostly related to the chips. Okay. So according to the close relation, we will get some outcome related to chip. Okay. So for example, we can define at first the get similar token. So to check the cosine similarity, we are defining the check similar token function. Okay, where we can take the following arguments like query token, k, embed. This type of arguments we will check. Just a second, one comment has arrived. Keeps updating the graph. Yes, sir. So it will update. from epoch 1 to epoch 2, epoch 2 to epoch 3, epoch 3 to 4, and 4 to 5. So it will keep on updating. Okay. So I'm mentioning for all the respective participants that it will take some time. So do not worry. Make sure that the coding portion has run successfully. The graph will definitely come up as its full-fledged version after 20 to 30 minutes on an average. Okay. Now let us go back to our discussion. So we will define W with embed.wait.data, and then we can define small x where we can run this particular W function over the vocab of query token. Okay, to compute the cosine similarity, we will use the general formula of the cosine similarity. If you are checking this cosine similarity between x and y from our standard mathematical knowledge, we know x transpose y divided by x norm into y norm. Now you see that the cos function is defined with the in numpy dot product w in wx, okay, divided by numpy square root, okay, numpy dot sum by w into w, x is 1, and another is in numpy dot sum x into x, where we, for our calculation, ease of the calculation purpose, we have kept it, okay, 10 to the power minus 9 for the numerical stability. Okay, then what we are doing that in px dot top k, we are taking the first argument as cos, okay, as we are checking the cosine similarity. Then what we are doing, we are adding the iterative steps, k equals to k plus 1, red type indices, okay, and which as dot numpy dot as dot type is in 32, okay. Then what we are doing, we removing the input words. How can we do that? For I in top k 1 onwards, okay, and then we are printing cosine simulation, okay, cosine similarity. We are checking that it will take the dot 3 means it will take 3 up to 3 decimal digit, okay, after in the floating point section. So float cos I up to vocab dot index to token I, okay. So then we are printing get similar token chip 3 net 0. Okay, now you see as the count is 3, we will print the 3 similarity word related to chip, okay, and the similarity index value will be printed up to 3. I mean, it will be in a floating point structure. So you are taking up to 3 decimal points because you see float cos I dot 3f, in this way you have defined. So after running this portion of the code, you will see that cosine simulation and output are getting your 0.464, okay, it is indicating microprocessor, okay. Cosine similarity 0.461, it is indicating bug related to chip, okay. Then you see cosine simulation 0.454, it is related to Intel chip, okay. So in this way, cosine, with the help of the cosine similarity, you are getting all the consistent word closest to the meaning of chip, okay, or relevant to chip. So you can check their cosine similarity and the relevancy of the word. Okay, so in this way, after applying the word embedding model, you can measure the cosine similarity among the different tokens or the words. Here we have tested it for the chip. Okay, and we have printed the three similar results. And that's the reason you can get the 3 results. So get similar token. You will put the first word, what you want to measure the similarity, then the number of the count of the words, and then the net 0. So it will give you the relevant outcome. Okay, so what I am doing, I am just posting this portion of the code in your comment box section such that you can execute it successfully. So let me know once you are able to see the 3 most closest outcome with the help of cosine similarity along with the word or token chip. So this is 12:45. So I'm requesting all of you to complete the step by 12:46 or 12:47. Take 1 or 2 minutes kindly to complete this particular step. So kindly confirm in the comment box section that you are being able to run it successfully. Good answer. Okay, thank you, sir. You have got Pankaj, sir. You have got the great results. Okay, so cosine similarity for Intel microprocessor and Apple in your system. You have got that. Thank you, Raju, sir. Thanks for completing the step. So let us wait for a few more seconds, and then we will move to the summary portion of this notebook. So basically what we have done, what we have learned from this section, basically you can see that we can pretend a skip-gram model through negative sampling. Okay. So that was the message we have incorporated here. And several other things we also have done. If you see the overall scenario, first of all, we have installed the necessary packages. And then what we have done, we basically defined the embedded layers. Okay. Followed by the skip-gram model forward calculation. So we have defined the skip-gram function. Okay. And followed by that, we have checked some of the output shape of the skip-gram computations by applying skip-gram function over certain simple examples. Then we have incorporated the loss function with gluon.loss.sigmoid BC loss function. Okay. After defining the binary cross entropy loss function, we move to the next portion of initializing the model parameters. Then we have trained the system, and after training the system, we saw that with defining the learning rate 0.01 and the number of epoch 5, you can see as the epoch progresses, the loss will be reduced. We also have seen that basic application of word embedding model, that for example, if we want to check the cosine similarity of a word related to or a token related to chip. So for example, in my case, I got microprocessor bugs Intel as per the cosine similarity value. In some of the cases, people are getting microprocessor Intel, Apple. So it depends as per the systems and scenarios. So anyway, so all of you have been successfully incorporated this particular notebook. Let me check what others are saying. Okay. I think just a second. I think this is Sumiran Sir's output. Okay, Sir, system is taking a got the result. Cosine similarity of Intel's semiconductors disappointing. Okay, that is output. Okay, so somehow the chip related information was disappointing, so it has printed it here with the cosine similarity of 0.447. So those results are very interesting, right? So you can try it out by yourself and check out and play around with several types of interesting results. So it is already 12:50. So should I move to another notebook or should we conclude it here? So I am leaving it upon the respected participants because our time limit is up to 1 p.m. So that's the reason I'm asking, because you will have another session from 2 p.m. So should we move for the another one notebook or just we should conclude here? Let me know with your by commenting in the comment box section. A really interesting results, sir. So I am requesting, I am leaving it upon our respective participants. Kindly please let me know that should we conclude here or we should move further, because we only have 9-10 minutes left you will have another session right from the 2 p.m. So just give me your precious feedback. So can anyone, any of you can write in the comment box section? So I'm just leaving it up to you. I mean, I hope that all of you are not bored. Okay, so you are finding this session interesting. So really interesting results. Thank you very much. So are you finding this session interesting? Okay. Shubhashree madam, it is already 12:51. So should I move to next notebook or should I conclude it here? I mean, you have the another session from 2 p.m. That's why I'm asking, because.
But sir, you can continue because it is indeed a very interesting.
Okay, okay. So I'm just covering one more notebook. Okay. So I will try to finish it within 110 or 150.
All right.
Okay. Thank you, madam. So I'm requesting all the respected participants to open a fresh notebook. Okay. So here we will see this subword embedding. Okay. So what does it imply? So I'm just going a little bit faster. So I'm requesting all of you to kindly excuse me in that case, because notebooks will be shared with all of you. So just open a new notebook, give some name, okay, and then just incorporate the results for you, and I hope it will boost your confidence in this domain. So what is the subword embedding? In generally, what happens that in English word, we have the different internal structures and formation methods. So for example, we can deduce a relationship between dogs, dog catcher, okay, by their spelling. So what happens that but all those words have this some root word, and the root word is dog. Okay, they can be used in different aspects as per adding the suffix. Okay, you can do it dogs or dog catcher. These are, we can add those suffix and you can utilize it for the different prescriptive cases. Okay, same thing you can do it for the cats. Okay, cat catcher as well, where the cat is the root word. Okay, or while establishing the relationships between boy boyfriend, or for example girlfriend. So same things happen. Okay, but you see that to incorporate, in fact, the morphology study, doing the morphological study is an important aspect related to the linguistic, where what we do in generally, we go with the detailed study of the internal structure and the formation of the words. So here we are going to discuss a very important aspect, that is fast text. Okay, so in what to bake, we did not directly use the morphological information. Okay, so what we do in both of the cases, what we have done, if you see the skipgram model, or for example the continuous bag of word, in both the cases we generally use the different vectors to represent the words in the different format, right? So for example, dog and dogs are represented by two different vectors, while establishing the relationship between these two vectors is not directly related to the model. Okay, so but in Bujanowski in et al. In 2017, they basically came up with the one of the important aspect of the fast text, which possesses the method of subword embedding. Okay, thereby attempting to introduce the morphological information within the skipgram model in word to vec. Okay, so in fast text, what does we do? We basically, for each central word is represented as a collection of the subword. Okay, so for example, if we see that where is an example to understand how these subwords are formed. Now, if we define like that, so we can add some special character at the beginning to distinguish the subwords as prefix or suffixes. Okay, so if we treat the sequence of the character to extract the n-grams, okay, if we are putting, for example, n equals to 3, so we can keep the subword as a length of 3. So for example, WH, WHE, HER, ERE, RE. So WH and RE we are keeping among the n equals to 5. We are extracting the n-grams. Okay, so we are putting WH and RE at the initiation and at the end. Okay, and in the meanwhile, you can see this 3 subword part. So WHE, then shifting to another HER, then again we are shifting to another word, ERE. So in this way, how we are doing? We are basically extracting the n grounds. So here n equals to 3. Okay, where the special subword is where, from where we are extracting the several chunk of the characters, okay, which we are defining as the n grounds. So in the first text, what is happening, that for a particular word w, if we record the union of all the subwords of length 3 to 6, okay, and the special subword we are defining it as the wg, thus the dictionary you can consider is the union of collection of the all the subwords related to all the words. Okay, so if we assume that the vector of the subword g, we can define it in the dictionary zz, and the central word is word vector is the uw, then what will happen? We can express the skip-gram model or SGM in this format, that u of w by the summation is where the summation is executed upon the zg. Okay, so rest of the first text process is more or less consistent upon the skip-gram model. Now, if we are going with the bit pair encoding, so in the first text case, what is happening, that the subwords have some specific length, for example, 3 to 6. So thus the vocabulary size cannot be predefined. To allow, you can see that variable length is there. You cannot predefine the vocabulary size. So to predefine it, what you can do, to allow for the variable length subwords, okay, in a fixed size vocabulary, we can apply a particular compression algorithm. So this compression algorithm, we call it as the bit pair encoding, or BP, to extract certain subwords. So Senrich et al. Has a very significant paper on them, 2015. So all of you are understanding this scenario, that we can have the variable length. Okay, to allow the variable length subword in a fixed size vocabulary, we are applying one type of the compression algorithm, that is the bit pair encoding, to extract the subword. So the courtesy goes to one of the prominent scientists in this particular field, Senrich. Senrich et al. Has developed in 2015. So what will happen then? So by the bit pair encoding, if you do the statistical analysis on the training data set to discover the common symbol within the word. Okay. So by defining the bit pair encoding, and its variant has been used for the input representation for many popular natural language or NLP pretend model, such as GPT-2, which has been defined by Radford et al. In 2019, and Robert A, okay, which has been defined by Liu et al. In 2019. So what we'll do, we will see some following simple examples related to the execution of the bit pair encoding works. Okay. So first we initialize the symbol, okay, with the English lowercase letters, which is end-word symbol is underscore, and the special unknown symbol UNK is given there. So you see that what we are doing, import collection, simply writing import collection, then we are giving symbols. So A to Z small letter is there. Another, at the end of the word symbol, you are seeing that there is a underscore sign, and UNK special symbol has been given there. So I am simply copy pasting this particular portion of the code and sending you it in the comment box section. Okay, just requesting all of you to execute it as fast as possible. Okay, because we are it is already 1, so we have to finish it by 1:15. So here you can see, for example, that we are not considering any symbol pairs as the cross boundary of the words. Okay, so what we can do, for example, so this special symbol underscore is appended to each word so that we can easily recover a word sequence. Okay, so how can you do that? For example, a taller man. From a sequence of the output symbol, if we are keep on extending this underscore sign, then what will happen? A taller man will become a underscore taller underscore man. Okay, and tall and ear, we are giving space. So since starting the merging process, forming a vocabulary of only a single character and special symbol, the space is inserted on the every pair of the consecutive characters, okay, within the each word. Okay, now in other words, the space is a delimiter between the symbol within the word, you can say. So for example, if we are defining raw token fake, okay, with the help of first 4, faster 3, tail 5, and taller 4. In this way, we are defining it. And now what we are doing, we are executing it under the for loop token freak in raw token freak items. Okay, what we are doing now, token freak, we are putting the space dot join list token. We are assigning it with the raw token freak token, and then we are calling token fix. Okay. Then you can see that as per our assigning fast 4, faster 3, tall 5, and taller 4, the appearance time or the corresponding frequency of their appearances has been developed, has been mentioned in the outcome. So you can simply incorporate those things. Thank you, Somadev sir, Sujata madam. So I am posting this next portion of the code. Okay, just to make sure that you are being able to generate the raw token word along with their occurrence frequencies. Okay, fast 4 times, faster 3 times, tall 5 times, and taller 4 times. Okay, so we can define the got max frequency pair function by returning the frequent pair of consecutive symbols in a word. So where the word comes from the keys of the input dictionary token freak. So how can we do that? So to build that, the max frequency pair as per their occurrence of the maximum frequency. Okay, so max frequent word, how you are doing it? So first of all, the argument has been taken as the token freak. Then what we are doing? So we are defining the pair with collections.default dictionary function, and then for token freak in token frequency items, symbol has been defined token.split function. And then what we have done for I in range length of symbols -1. Okay, so key of pairs is a tuple of 2 consecutive symbols. So that has been defined. So pairs will be definitely with symbol, comma, symbols +1. Okay. And then we are returning the max of pairs and key equals to pairs.get, such that we can generate the key of pairs within the maximum value. So just putting this particular chunk of code in your comment box section. Okay. Okay, so all of you are getting the correct result. So thank you, Somadev sir, and all those who have kindly make your comment. Thank you, Raju sir. Okay, for the shortage of time, I am not being able to acknowledge everyone. So those who are commenting, thank you very much for your kind support. So I am just pasting the next part of the code in your comment box section. Please confirm me whether you are being able to run the function successfully or not. Here we are defining the get max pair. Okay. So in the next section, what we'll do, because you see the greedy search-based approach, if we apply over the frequency of the consecutive symbol in order to make the byte pair encoding, which will execute over the match symbol function. Thank you, Somadev sir. To match the most frequent pair of the consecutive symbols to produce the new type of the symbol. So what we will do, we are defining the match symbol function. Okay. So under the match symbol function, you can write 3 arguments. So max freak pair, okay, token fix, and symbols. So symbols dot append, what you can do, you can join the max freak pair. Okay, and under the token and under the for loop token, you can define the freak in token freak items. Okay, you can define the new token. So token dot replace will be join max frequent pair. Okay, and then what we are doing, then we are defining the new token, freaks new token, where we are applying the token freak over the token. Okay, then we are returning the new token freak as an outcome. So in this section, what we are doing, we are merging the symbol, which is a part of the greedy approach. Okay, for the consecutive frequency of the consecutive symbol in order to define the byte pair encoding under the match symbol function to merge the most frequent pair of the consecutive symbols. Okay, so I am posting the next part of the code in your comment box section. Just let me know whether it is running or not. Okay, then in the next section, what we will do, we will now define the iteration, number of the marches. We are done with the greedy approach, where we have defined the new token freaks. Okay, now what we will do, we will go to the iterative performance checking for the bit pair encoding algorithm. Okay, so in the first iteration, what will happen? The most frequent word pair of the symbols will be combined. So for example, T and A, followed by what will happen? Then the byte pair encoding will merge to construct a new symbol, TA. Okay, and then the second iteration, what will happen? It will again continue to march. Okay, TAL. So in this way, you see that you are continuously merging it and you are getting the corresponding outcome. So thank you, Somodip sir, Sujata madam. Okay, now what we are doing, so number of the merges we are keeping 10. Okay, and for I in ranges of the number of the merges, maximum frequency pair, how we are defining it? Get max freq pair with applied over the token freq, and the token freq has been assigned to where the merge symbols has been applied over the max frequent pair, token freq and symbols. And how you are printing it? You are printing it in following manner. Merge I plus 1, where the hash sign 1, 2, 3, 4 in this manner it will come up, and you will get the possible frequency pair margin. So in the first case, you see merge 1, how the output is coming up. I'm just explaining. TA in the merge 2, TAL in the merge 3, TAL, comma L. Okay, completed. Then again in merge 4, FA, in merge 5, FAS, merge 6, FAST first, completed. Merge 7, ER, merge 8, ER underscore. Okay, that means R. Okay, as per our definition. So it was given like faster underscore, tall, faster. Then what is happening? It is also tall underscore, merge 10, fast underscore. So whatever the given possible outcome, it is pairing and it is giving you the merge outcome. So you have got the outcome, merge outcome for the 10 iterations. I have posted the code in your comment box section. Kindly let me know if you are getting the merge 1 to merge 10 with the proper outcome. Okay. So in the next case, if you see, for example, what we have got, after the 10 iterations of byte pair encoding, we can see the overall list of the symbols. Now, in the case of the overall of the list of the symbols, you'll be able to see that those 10 possible outcome has been merged with the earlier symbol list. So we had earlier A to Z, then underscore, then UNK, and we along with that, this 10 updated result has been added. You see, all those results has been added here as per the outcome you got for the 10 merges. You see, TA, tall, FA, fast, etc., etc. So what I am saying you, suggesting you, just all of you, what do? You just simply run the print command over symbol. You will be able to see all those possible outcomes. So thank you, sir. Already you have run it successfully. So what I am doing, I am just printing it over this symbol, and you will be able to see that those 10 merged outcome has been appended with the earlier outcomes. Okay. Thank you so much, sir. This type of outcome you will be able to see. Okay. So in the next case, what we will do? In the next case, for the same data set specified in the keyword dictionary with row token freqs, okay, each word in the data set is now segmented by the subwords. For example, fast underscore, fast, year underscore, tall underscore, and tall as a result of the byte pair encoding algorithm. Okay, so for instance, word faster and taller are segmented as faster underscore, okay, fast space underscore, tall space year underscore respectively. So we can, what you can do, you can list, we can keep it as the list token freq keys, and you will be convert them under the list. Okay. So let me just a second, let me post that portion in your comment box section. So once you are printing the list of token freq keys, you will be able to see that it has been listed. All those sequences has been listed. Fast underscore, fast space year underscore, tall underscore, tall space year underscore. So you can see all those token freq keys has been listed. Okay. So the result of the byte pair encoding depends upon the data set you are using. Okay. So we can also use these subwords which we have learned from one data set to segment words of the another data set. So as a greedy approach, the following segment underscore BPE function tries to break words into as longest as possible. Okay. So what you will be able to observe. So here what we are doing, we are taking the segment BP function where two arguments we are taking, token and symbols. Okay. So for token in tokens, okay, we have defined start and end as 0 and length of the token, where what we are doing now, we are initializes the current output and then the segment token with the longest possible subword from the symbol. So how we are defining, while start less than to length of token and start less than to end, if the token is executed start to end in symbols, the current output happen token start to end, start now initialized to end, and end is now initialized to length of token. So either you can do it under the if loop or if condition, or else end equals to n minus 1. So if start less than to length of tokens, what will happen? Then your current output will be happened up to UNK. Okay. So output happened where you can do the joining operation with the current output. So return, it will return in the mode of output, where the function is basically your segment BP function. Okay. Where we are executing the grid search to break the words into as largest as possible with the help of the token and symbols arguments. Okay. So I'm just posting this portion of the code. Okay. Thank you. Thank you so much, sir. You will be able to see this type of the outcome. So now what I am doing, I am posting this portion of the code. You just check it. So now what we will do, we will now execute. We will take the token of the tallest and fatter. And then what we will do, we will apply the segment BP function with token and symbol argument, and we will see the effect. So I'm taking this portion of the code and posting it in the group. You see, once you are applying the segment BP function over tokens and symbols, where the token values are tallest and fatter, you see this type of the outcome you are getting. Okay. So in the following section, the subword in the list symbols, which is learned from the aforementioned dataset, to segment the tokens that is present in the dataset, you will be able to see this type of the outcome, where tallest and fatter will be generated. Thank you very much, Raju sir, for the confirmation. So this was all about the executing of this subword embedding. So what we have learned in this portion. So first text proposes a subword embedding method. So based on the skip-gram model or SGM model in word to vec, it represents the central word vector as the sum of the subword vectors of the word. Okay. So central word vector we are representing as the sum of the subword vectors of the word. Subword embedding utilization of the principles of the morphology. So once you are breaking the word into subword, you are basically studying the morphology. Okay, so which usually improves the quality of the representation of the uncommon words. Okay, and white pair encoding. Okay, performs a statistical analysis of training dataset to discover the basically the symbols within the word. So as a greedy approach, white pair encoding iteratively merges the most frequent pair of the consecutive symbols. So this is the learning from this particular part of the subword embedding. Thank you, Raju sir, Samili madam, for executing it successfully. Okay, so I believe that this particular session was helpful to all of you. Now over to you, madam. As per my promise, I have been able to complete it within 1:15. Okay.
Yes, perfect, sir.
Okay,
So
thank
it
you.
was really a
Thank
very
you so much,
interactive
sir.
session.
Thank you so much, madam.
So with this, we come to the end of second session. It was indeed very interactive. It goes without saying, as we have already seen throughout the session. So, and your enthusiasm, sir, was really contagious. So all we can see is the chat box full with the output, the outcome that the participants have got. So I would like to thank you again, express our gratitude towards your presence and sharing your valuable knowledge to us. I'm sure the participants would add some value from this session. Now, since this year it is a virtual gathering, so I would like to present a certificate as a token of appreciation to you. So kindly accept this. Am I audible, sir? Are you here?
Thank you very much, madam. Thanks for the for this token of appreciation. It looks beautiful. Thanks to the designing team as well, who has put their effort to design this beautiful certificate. And I am thankful to IM Fraternity for inviting me here in this ATAL AICT FDP. Thankful to Shubhasri Madam to conduct this session in overall and monitoring and helping me out in some cases whether I'm properly audible or not, or executing the session within proper time. And obviously, finally, I am quite thankful to all the participants for their active participation, because you see, in the virtual mode, without your active participation, the session was not being successful enough. So please share your precious feedback, and definitely I will share these notebooks to all of you. I will send it to the organizers, so they will definitely share with all of you. You can go through them, and you will get. I hope that all of you will be benefited. Okay, so you can, Sujata Madam, you can start from the notebook 1. Okay, that starts from the very basic level of NLP. Okay, and if you follow the notebook, all the relevant theory and code part is there. So do not worry. And what I'm doing, I'm just sending my mail ID as well, in case if you require any help in future, you can send me the mail there. Okay, so you can send email to this particular mail ID for any further confusion or doubt. Okay, so I will definitely reply. Thank you very much again.
Thank you, sir, for sharing your IDs. So I'm sure people would be able to, ask question or query if they have any. So with this, we come to the end of our session, the second session. Rather, the first two sessions was very, very interactive, hands-on session completely. And we thoroughly enjoyed the session. There is no doubt in it. So thank you very much, sir, for your presence. We look forward to see you again in other events as well. Since our participants have been, interactive and very alive throughout the session. Thank you, sir, for your presence.
Thank you very much, madam. Thanks a lot.
So with this, we come to the end of the second session, and we would be going for a short break now. And I would request all the participants to be here again at 2 o'clock, where our third session for the day would start, which is the sixth session for the FDP. So I request again all of you, please be on time so that we can start the session right at 2 o'clock. Thank you so much. Thank you, sir, for your presence.
Thanks. Thank you.